Hi there, my name's Bruce Rain from Breakers Creations, and in this video we're going to find out the contents of these two bags and if they can be restored. I have a friend that scours the local markets looking for bargains, and anytime he comes across anything Apple related, he sends me a message. I give him an idea of what it's worth, or if it's something I'm interested in, I just buy it straight from him. Well, this morning I woke up to a text message from him saying that he had bought these and asked if they were worth anything. Well, I explained that they potentially are, depending on the condition they're in, but they'd need to be assessed, and he really had no interest in doing that whatsoever. So he told me what he paid for them. I then made him an offer and he accepted it. I picked them up this morning and now I'm going to open them up and find out if I got my money's worth. Let's start with bag A. So I have got here a mouse, very yellow, decrepit looking mouse, but a mouse suitable for the older style of Macs, things like the original Macintosh 128K, 512K, 512KE and Macintosh Plus. I have got an external floppy drive, and here I have a Macintosh 512K. So let's see if there's anything else in our little bag of tricks. Nothing else there, but I do have something else that came with it, but not in the bag. A keyboard, but no keyboard cable. Macintosh 512K. So this was a computer that came out in late 1984, replacing the original Macintosh, which had 128K of RAM. It was never really enough. So they brought out the 512K, which also known as the Fat Mac. The next model to come after the Macintosh 512K was the 512KE. The big difference being it had an 800K floppy drive instead of a 400K. And it also was quite common for the Macintosh 512s at the time to be upgraded to the 512KE. And it'll be interesting to see if this is one of them. The way we can tell is we'll have a little look into the floppy there, and that actually looks to me like the original 400K. So this I don't think has been upgraded. But just as I tipped that back there was a sound that I did find a little bit worrying. And that was the sound of stuff crumbling around inside it. So this could just be a rusted lump inside. We'll have to have a look and see what it's like. I'm going to put this on its front, ready to dismantle it. There are 5 screws we need to remove, 2 from in here, 2 from here, and 1 from underneath the battery cover. So I'm going to do that. Oh, the battery is still in here too. Look at that. There is a lovely corroded battery going on in there. There's our old battery. This is a 4.5 volt battery, a 523. Apparently you can just put a 1.5 volt AA in place of them, but I actually have a little 3D printed case that I have that allows me to stick in 3 LR44 batteries and get the 4.5 volts that way. So that can go. If you are going to open these, it's always a good idea to have one of these long T15 Torx drivers. It just makes life so much easier pulling these things apart. So I'm going to undo these two. That's rust. I have, in putting that down, just ended up with rust on the table there. So that's a bit of a worry. Rust everywhere. I would be lying if I said I wasn't concerned about the state of the inside of this computer. So now we've got to get the case off. I'll just do that with my hand. I can see the original 400K floppy drive there. If you're going to have one of these computers, I can pretty much guarantee you they will be seized solid. They need to be reconditioned. All of the old grease needs to be removed. They need to be relubricated, and sometimes there's other problems with them as well, but we'll see what happens with this one. Now here's an interesting little mod. Someone has installed a fan inside this. Right in there is a fan that someone has mounted on the side of the floppy drive bracket, and it looks like it's aiming air down at the logic board. Now I can also see a little surprise. So I am going to remove this logic board and we can see what this little surprise is. Okay, let's tip it back up again. Yay! There we go. And wow, there's something else. We have an exploded reefer capacitor. I'm glad that it's exploded in someone else's house and not mine, because I don't like the house smelling like reefer, you know what I mean? Here is the board. And what we have here is a Zyber Excalibur upgrade. And this here, I guess, is part of it as well. Copyright 1985, Sophisticated Circuits V1. That is a little bit of treasure. Now, the one good thing is that this logic board is in pretty good condition. There's a lot of corrosion on the connectors here, but to be frank, most of those can be replaced or just clean them up. The actual logic board itself is in remarkably good condition. I don't see much in the way of corrosion, a little bit there. I wouldn't be at all surprised if I gave this some power and it just worked. On the other hand, in this part of the world, we have got some really serious rust going on all around here. That'll all need to be cleaned up. The analog board, well, we've got some corrosion around here, but I reckon after a recap and a clean, this might work as well. And I suspect that a lot of this rust and corrosion is really just surface problems. So maybe after a bit of restoration work on this, we'll be able to get this analog working as well. And the actual CRT itself looks fine. It doesn't appear to be damaged. All in all, it would appear that all of this grit falling out of it is actually not as bad as you would originally think. So this particular one, I think this one has definite restoration potential. So here is the logic board. The original 512K logic board is on the bottom, and then we have this Zyber Excalibur board floating on top. This has got a total of 48 sockets on it. At the moment, 16 of them are populated. They're populated with 32 kilobyte chips. So 16 of them will give you 512 kilobytes. So my guess is, with the 512 already on the board, plus that will give a total of 1 megabyte. If fully populated, this board would be able to hold 1.5 megabytes, so I would assume that would then take this up to 2 megabytes. Now, it's my intention to actually go and buy a whole bunch of these chips, fully populate this board to see if we can take it up to the full 2 megabytes. We also have this ROM upgrade here, and I'm almost certain this will give this the capability to read 800K floppy disks. The fact that it came with an 800K floppy drive makes me pretty sure of my theory. But before I do anything, I want to test it out and see if it works. This is my other Macintosh 512K. This has actually been upgraded to a 512KE, and as you can see, it functions beautifully. I'm actually going to use the analog board from this to test the logic board of the new 512K. Okay, well, I've got the logic board plugged in. I haven't done any other testing of any type. We're just going to give it that first go to see whether it works. I'm giving it about a probably 50-50 chance. Let's see what happens. Well, you can see we have got a sad Mac face and a couple of little vertical lines, and that's usually an indication that we are dealing with a RAM problem. And that's not at all surprising. It's the most common failure on the logic board of a 512K. Right, now I can confirm that that error that we got means that we do have a problem with one of the RAM chips. It actually says at location F7. That's the one where we would have a problem. But given the fact that we've got this upgrade on here, it could be anywhere. I feel like the first thing I need to do with this is actually take the upgrade off and try and test this as the original board. Okay, well that's the upgrade board removed. And we've got these little pins that go into those sockets there. And these little pins that go into there. So this is an original 512K board, and you can see what a task it is to actually upgrade this. They've taken these little resistor nets off the board. They've actually had to desolder them and then put in these sockets that then attach onto the upgrade card. And then they've had to take these two chips out. This is the LS244, two LS244s. They've come out and they've put sockets in so that we've then got the sockets here. So for me to restore this to its original condition, oh, and then this chip here has been removed as well. So, gosh. So it looks to me like restoring this back to an original 512K board would be an absolute pain in the backside. So I don't think I'm going to do it. I think what I'll do instead is replace the RAM chip, which is coming up as faulty, which was F7, and then we'll put it all back together and try again. Now, knowing that these chips can fail, the sensible thing to do is, rather than just solder in a new chip, I'll actually put in a socket. So should this one ever need to be replaced again, or if, heaven forbid, the one I put in is bad, I can just swap it out nice and easily next time. So let's have a crack at that. Alrighty then. It's still saying 0204. Well, so far I have identified two failed RAM chips, and I have replaced them both, and as you can see, I've actually made quite a bit of progress. I've actually been able to boot into an operating system, and if I go here to About the Finder, we'll see that it actually says 1024K. So it is actually recognizing the extra 512K of RAM installed. But you will also notice that I have these rather ugly vertical lines. Now this is almost definitely still an issue with one of the RAM chips. It's just a matter of identifying which one it is and replacing it. I may end up having to go in and replace a whole stack of them. And the unfortunate thing is it's the RAM on the original board, not on the upgrade. So every time I want to replace a chip, I have to take the board off, remove the old chip, put the new chip on, and then stick the upgrade back on again to test it. So it's a fairly tedious process, and I honestly don't know how long it's going to take me to get through them all. But that's kind of where I am at the moment. I decided to do a bit of future proofing, so I removed all of the RAM chips and replaced them with sockets. So if in the future, if any of the chips fail, I can just whip out the old one and pop in a replacement. Just like that. I managed to find the issue with the black vertical line. We've got a schematic here, and we've got these video signals here, VD0 to VD15. So there are 16 of them. Each one represents a vertical line on the screen, and then it just gets repeated. Now that black line was happening every 16 pixels along, so I know it's an issue with one of these video signals. Now they get split apart and they go through these two 8-bit shift registers, the LS166 chips, which are just here. Sorry, just there. What I ended up doing was I removed them and I put in some sockets, of course, to make things easier, and I swapped them around. Now, because they're an identical chip, in theory, if I swap the two over, nothing should change. But what happened is when I did swap those two chips over, I got a different output. Swapped them back again, and it went back to the original output. So that tells me that one of those chips is not running in the way it's supposed to be. So I was able to actually salvage one off an old Mac Plus board that I have, an old donor board, because they use the same chip on the Mac Plus. And I was able to find out which one it was and replace it. And now the image is perfect. However, after doing all of the work on these RAM slots, I've lost 128 kilobytes of RAM for some unknown reason. So I've got to try and figure out where it went. So now I have 3 remaining problems with this logic board. Trying to figure out where that 128 kilobytes of RAM ended up. The sound is not right. If we play a sound, you can tell that's clearly not correct. And then the other thing is it doesn't seem to boot into System 4.1, and the 512K should boot into 4.1, so I need to figure out what's going on there. And now it is time for bag B. So let's see what is inside. I have got a keyboard cable and a power cable. It is an ADB keyboard cable, so we know it is a later compact Macintosh. We have got a mouse here. There we go. And tucked away over here, I have this ADB keyboard, which wasn't in the bag, but was included with the package. And we have a Macintosh SE30 with some very interesting discoloration going on here. We've got the super bright orange going on here, and this sort of, I don't know if someone's had a go at cleaning it, but who knows. So the Macintosh SE30, which came out in 1989, is one of the more collectible Macs because of its expandability up to a full 128 megabytes of RAM. It was the fastest of the original compact Macs, so it's time to have a look and see what the state of this one is. This one doesn't sound as crumbly as the other one, but it is rattling. It has 4 screws. Once again, very rusty. There's also is missing the cover on the back, which suggests that it may, at some stage, have had some sort of upgrade. Either that or someone's just lost the cover. Okay, so this says Nortel Ost. They have engraved the serial number of the computer up here when the serial number is just there on a sticker. Well, why not? Someone obviously got hold of a new engraver and wanted to use it. I can also see corrosion on the terminals for the power connector. So, once again, expect the worst. Oof. Once again, very rusty. Well, this one's even rustier than the other one by the looks of it. Now, of course, with these old computers, the one thing you absolutely should not do is power them up without inspecting them, which is why I am actually inspecting it. Time to remove some bits. I am just disconnecting the floppy and the SCSI cable. The floppy and hard drive are just floating around inside there. Come at this from a different angle. There we go. Okay. Now that is a part out of the floppy drive, so that does cause concern. Right, so this here is one of the later model SE30 boards. I can tell that because it has a grey CPU there, which is soldered onto the board. It's not in a socket. The earlier ones, they had that ceramic and gold CPU, and it was sitting in a socket. They also had this little capacitor here, was down underneath the ROM. So they made a few little revisions to the layout of the board for this later version. But one really, really good thing here is that this battery is still intact. It has not exploded, and even though I can see all of this rust from being stored probably out in a shed or something like that, this connector here is completely shot. The board itself is in really good condition, and I wouldn't be at all surprised if after a bit of a clean and a recap, this would just fire up. Looks like it has 4 megabytes of RAM. These look like 1 megabyte SIMs. But the first thing I'm going to do here before I do anything else is get rid of this battery, which is 1289. So this is the original battery. It's the TWEEZERS. There we go, 3.6 volt lithium battery. It's the original, and it has not exploded. So that is a nice little surprise. So the logic board itself, pretty good condition. I think pretty straightforward to restore that. The screws have been removed for the drive assembly. I'm not quite sure why that's the case, but they have. I'm going to take this little bracket off the back so that I can remove this without any danger of damaging the CRT. Look at all the corrosion we've got going on here. It's going to need a little bit of a buff. Oh look, here are two of the screws from the bracket, just floating around inside. Someone has had this open at some stage because there's a couple of screws missing. So maybe someone's had a crack at getting it up and running. Here's another little piece out of the floppy drive. I think we can fairly safely say that this floppy drive is cactus. Almost looks to me like someone has just had a go at making it work by using a hammer. The analog board itself doesn't actually look too bad. I don't see any swollen caps, and they all need to be recapped, but it really doesn't look too bad. I wouldn't be at all surprised if I put some power into this and it just fired up. Okay, and we have got, this is the genuine Apple drive. We've got our little Apple logo down there, and this is an 80 megabyte hard drive. So I'll be really interested to see if this still spins up and whether there's any data on it. So despite all of the corrosion, I still think this is a computer that can be restored. So the next step will be to take it all down to the workshop, start pulling it apart, cleaning it up, getting it ready to power on. Here is the SE30 logic board, and I can clearly see some leakage around these capacitors here. Now, if you're not familiar with the concept of recapping, basically these are electrolytic capacitors and they have a limited lifespan. And in particular, these little surface mount ones, when they get old, they can actually leak, and they can leak electrolyte onto the board. And that can end up causing corrosion and all sorts of problems. And I can clearly see that happening here. So all of these capacitors will need to be removed and replaced. Now, having said that, it does look bad, but it doesn't look as bad as I have seen. And I'm going to do something that I don't normally do. I'm actually going to power this up and see if it starts as is. I'm still going to recap it anyway, but I'm just curious to know whether this actually works in this condition. So I've got myself a ZuluSCSI Slim. That's got to be the smallest external SCSI emulator I have ever seen. And can I get that onto the plug there? Geez, it's a little bit rough. I might just clean that up a little bit. I have a Dremel here, and I have one of these little abrasive buffs on the end of it. So I'm going to just run around that connector and just try and get rid of some of that rust so that I can actually get a SCSI device connected to it. Now, I do actually have brand new ones of these that I can use to replace this cruddy one, but just for the purpose of this test, cleaning it up is enough. This one here is absolutely terrible. They don't make these ones anymore, but I think I can probably salvage one from an old Mac Plus donor board. So that's what I'll do with that one there. So let's give this a go. I'm going to put the SCSI on there. That's the ZuluSCSI. Connect up a mouse. Now, the other thing I have is this really nifty little tool here from CayMac Vintage, and it is called an SE30 Compact. And what this does is it allows me to use a standard ATX power supply here and power up the SE30 without needing the whole analog board. And what it also has, it has this nifty little thing here which will convert the video signal into HDMI, so I can play the output on a modern screen. So if you're doing this sort of test work, one of these is absolutely essential. Now, this does go straight onto the board if you want to, but I'm just using an extender so that I can see the board while I'm working on it. And then last of all, we need a speaker so we can see if it's talking to us. Because generally if there's a problem with the board, it'll probably give us some sort of SADMAC chime or make some sort of noise. It helps in the diagnostic process. So now I am going to power it up. Okay. Okay, it chimed incredibly quietly, but it did chime. And it actually looks like I'm getting a video signal. It does indeed look like I'm getting a video signal. I'm just going, oh, and I can even move my cursor around. So there was a pause before it chimed, and that's certainly an indicator that those capacitors need replacing. The chime is very, very quiet. That's another indicator that the capacitors need replacing. And it looks like the video is a little bit wonky, but I suspect that will also be resolved when we recap it. But we've got the welcome to Macintosh. It's actually loading into a system, so it's actually reading off the SCSI. So it's all looking pretty good. Okay, just have a look here. There we go, 4 megabytes of RAM, as I suspected. Let's shut this down. Right, well, that was a fun little experiment, but it doesn't change anything. We still have to remove all of these capacitors, clean up underneath them, and then put new capacitors on there. I'll be replacing these electrolytic capacitors with tantalum capacitors that will not leak. I will be using a hot air station to remove these capacitors, being very careful not to melt anything in the process. I am also going to remove these electrolytic axial caps. And typically these are usually still okay, but if you're going to be replacing, may as well do them all. Now the next step in this process, we need to clean these pads up. At the moment it looks like they're beyond hope, but I assure you that once I actually finish, they will actually look nearly new. Well, better than they are now. And for this process, I'm going to be using a good quality flux. SteriFlux is the flux that I use. There are links in the description and a discount code. And also a bit of fresh solder and then some gentle heat and pressure on these pads to try and dislodge some of this gunk. Now I'm going to use some solder wick to remove all of the new and old solder and hopefully just leave some nice clean pads behind. I'm just going to put a little bit of UV solder mask onto these traces which I exposed while cleaning. Over here and over here. Now I'm just going to cure this UV solder mask using a UV light. Now I can put the new capacitors on. So this one here is a 1 microfarad 50 volt. I've just placed some flux onto the pads. Replacement capacitor in place. Stripe on a tantalum capacitor points to the positive. There's the positive on the silk screen. And then I'm just going to place a bit of solder onto my iron tip and solder the capacitor in place. And we do the same for the remaining 3 here. These are 47 microfarad 16 volt. Always try and get these as straight as possible, because if I don't, I look at them later on and think, oh, I really should have done better. Okay, that is 4 capacitors replaced. Now I just have to do the remaining 7. And that is all of the surface mount electrolytic capacitors replaced with tantalums. Now I just need to replace these 2 axial capacitors. I've replaced all of the electrolytic capacitors on this board, and I've also replaced the SCSI connector with a brand new one. The floppy drive connector has come from an old Macintosh Plus board. Now, it's not perfect, but compared to what was there before, it's definitely an improvement. The very last step I need to do with this board before I sign off on it is to clean it. I'm going to drop it into an ultrasonic cleaner so that it can get into all the nooks and crannies, get rid of all the dust and gunk, electrolyte, old flux, and of course any of the surface corrosion that's floating around on the board. So this is the before pic and this is the after. And there's only one thing really left to do, and that's to test it and see that it's still working. Okay, we got ourselves a nice little chime, and hey, we got a little happy face. Welcome to Macintosh. Okay, let's just have a look here about this Macintosh. And SE30, 16 megabytes of RAM, system 7.1. Looking good. So, this logic board now has a clean bill of health. Well, I feel like I've barely scratched the surface of these restoration projects and we're already 30 minutes in. You know what that means? There's going to be a part 2. If you enjoyed this video, please consider pressing the like button and subscribing to my channel. Do you have any idea where my mystery 128K of RAM might have gone? Please feel free to leave a comment. Thanks for watching.